As you and I issue the command show IP route to look at the IPv4 routing table on a Cisco router, on the far left, it's going to have that routing protocol code. Where did this route come from? Fantastic. And then following that, it's going to have the network as well as its mask. And it's that I'd like to discuss with you, that network and the mask, that I'd like to chat with you about right now. So to reinforce this, I would love you to join me in the hands-on lab, and we're on our admin machine, DCNUG, and let's open up MPutty, and let's open up a console to R1. And here on R1, let's look at the routing table. And the command for that, of course, will be show IP route, and then we'll press enter, and that's going to give us one page at a time. And we can just hit spacebar a couple times to go ahead and cycle through all the pages, and let's take a look at the very end. So over here on the left in this column, we have the routing protocol codes, which we covered in the previous video. And then next, we have the actual networks, followed by the masks. And let's talk about that for a moment. Now, fortunately, these are sorted for us these days numerically. So lower numbered networks will be before higher numbered networks, and it's easier to find things. That has not always been the case over the years, but fortunately it is now. And then for each of the networks, we're going to have this entry here. Because 10 is a Class A address, it's going to show us 10.0.0.0 with an 8-bit mask. And then below it, it'll show us the carved out networks and subnetworks that are included in that 10 address space. So even if we don't have any 8-bit masks configured anywhere, because it's a Class A address, it'll show up as this heading in the routing table, and then it'll show us the more detailed routes that we have in our routing table. So in short, this 10 network with an 8-bit mask is not a route. This is just a heading for these networks below that begin with 10. So let's talk about the keyword of network. And I'm also going to use the word street, because networks are very much like streets. And we could also use the word prefix, because oftentimes we're referring to networks by the name prefix. So whenever you hear the word network or prefix, we're simply talking about a network segment, an IP network segment. And these terms, prefix and network, from a routing table perspective, can be used interchangeably. So let's go ahead as an example and pick on this one specific route right here. So this route points to the 172.16.6.0/26 network. And just as all these 10 networks were under this heading of 10.0.0.8 because it's a Class A address, here we have this heading of 172.16.00/16 because the first octet of 172 means it's a Class B address, and then below it, it's indicating all the subnets. So for this one route, the network is 172.16.6.0, just as it appears, /26. Now, I've got a question for you. What would that mask be, just for grins, what would that mask be in dotted decimal? So if we went 2 bits further into this last octet, what would the mask be in that last octet to represent a 26-bit mask? And if you're fairly new to that process, one of the techniques I strongly recommend is just putting the numbers up here, 128, 64, 32, 16, 8, 4, 2, 1. Also, you can start from the right and just go 1, 2, 4, 8 and double it. So 24 bits is up to this point. If we had 2 more, that'd be this one and this one for the mask, and all the rest would be zeros. And then we just add those up. So 128 plus 64 equals 192. So the mask in dotted decimal would be 192. So if this router received a packet that was destined for 172.16.6. All right, so this is where it gets a little bit interesting. Because if I want to have a host that has an address in that subnet, I have to know what the range of that subnet is. So if I did a quick calculation, the block size for the subnets is going to be 64. So because the block size is a 64, that would mean the next subnet would be 172.16.6.64. So I'd want to make sure I had a host address on that real subnet. So if a packet came in and was going to 172.16.6. and let's put 50, that's perfect. The router would look at that destination IP address and say, well, my match is right here. This is the route. And as a result, it would go ahead and use 10.12.0.2 as its next hop, and its exit interface, its egress interface, would be gigabit 1/0. And it would forward that packet on to router 2, and then it would be R2's problem to process that packet and to continue forwarding it in the right direction. In this video, we've taken a look at the routing table with a focus on the network portion along with the mask included in individual routes. I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.